So in previous videos, we alluded to something called higher order observables, which is an observable of observables. So in JavaScript, you can have an array where you have some values, let's just say 1, 2, and 3 like this. And you can also have an array of arrays where you have like the first element is 1, 2, and the second element is like 2, 3, and the third element is like 3, 4. So here we have an array, an array where each element in the array is itself an array. Likewise with observables, we can have an observable of observables. So we could have an observable of that, and then an observable of each value. So we have here an observable from an array, and then each element is an observable of an array. So how would we subscribe to this? If we do subscribe console log and then try to run this, you'll see it's just logging out the observables themselves. So it logged out this observable here, this observable here, and this third observable here, but we can't actually do anything with it except subscribe to it. So what we could do is we could get each observable, and then on that observable we could call subscribe and pass in console log. Be one way to do it. But this is actually an anti-pattern in RxJS. So now, although we have gotten the elements themselves, you typically want to avoid nesting subscribe blocks like this because RxJS comes with built-in flattening operators. So rather than using a nested subscribe block, we could pipe this to the mergeAll operator, and then we could just subscribe directly to it. And what that will do is flatten it for us. So if we run this, we'll see it's essentially the same thing as having the nested subscribe block. We just get all the values. And if we look over here at the documentation, we can see mergeAll converts a higher order observable into a first order observable, or flattens it basically, which concurrently delivers all the values that are emitted on the inner observables. So here we have an observable, which is this arrow flowing from left to right, and the values on this observable are themselves observables, which are these observables projected out of it, which have the actual values themselves, A, B, C, D, E, F, G, and you can see here they overlap at different points, or at the same point in time, they overlap. And here with mergeAll, we get a single observable with all the values as they occurred over time. So we get a value from one observable interleaved with the value from the other observable, and back and forth. So here we have an observable of the numbers 1, 2, and 3 spaced 1 second apart. And if we subscribe and console log and go ahead and run this, we'll see we get 0, 1, 2, and then it completes. Likewise, we can have this observable of numbers where every 500 milliseconds we emit a number, and we're going to take only 3 of those numbers and then map it to a letter. And so if I subscribe to letters and run that, we'll see ABC. And if I create a higher order stream here, we can have a project function that takes in a number and maps that to letters.pipe and maps the letter to an array with the number in the letter. So what we're doing here is we're taking the numbers and then we're mapping each number to an observable of letters where the letters themselves are mapped to a tuple of the number in the letter. So basically what we're going to see here is this numbers stream will emit a number like 0, and then a observable will be forked off. So what we're going to see here is we have our stream of numbers where we emit 0, 1, 2, and then it completes. And for each of these, we're going to fork off this observable of letters where we're like A, B, C, and then complete. And then this 1 also causes us to fork off an observable where we're like A, B, C, and then we complete. Likewise, this forks off an observable A, B, and C, and then we complete. And so now the map letter to number letter, what that's going to do is give us an observable that looks like 0A, 0B, 0C, 1A, 1B, 1C, 2A, 2B, 2C. And so we'll get some combination of this output. So currently down here I have nested subscribe blocks because the value emitted on the outer observable will be the inner observables. And we have to subscribe to those inner observables to get the values themselves. So if we go ahead and run this, we'll see these are interleaved throughout time. So when the 0 observable, outer observable is, when the 0 observable is still going, the 1 observable starts. And then after the 1 observable started, the 0 observable emits its last value and finishes. But then before the number 1 observable finishes, the number 2 observable starts, and then observable 1 emits another value. So they're just interleaved with each other. So that's the same thing as doing mergeAll. So we can just have a single subscribe block and use mergeAll to flatten and merge the values and get the exact same thing. And so what mergeAll did was, if we draw some vertical lines here to look at the time, it did 0A, which is this combination, and then 0B, which is this combination. Then it took this value, 1A, and then it took this value, 0C, right? And then 1B, and then 2A, and then 1C, which is this value, and then 2B. It just did them in absolute order from left to right. We can compare this also to concatAll, which will run the outer observables in order. So as before they were interleaved, now we won't subscribe to a subsequent observable until a previous observable finishes. So now we completed all of the 0 values, and then only we subscribe to the 1 values. And then after all the 1 observable values completed, we subscribe to the number 2 observable. So it enforces order. What concatAll did was it first went down and did all the zeros. So it did 0A, 0B, 0C. Only after this completed, then it subscribed to the next observable and got 1A, 1B, 1C. Then only after the observable branched off of 1 completed, then observable 2 was subscribed to, 2A, 2B, 2C. It enforced the ordering of going down these branches one at a time. We could use exhaust. And so what exhaust does is it it did not subscribe to number 1, right? Because number 0 was not complete. Only until number 0 completed, then it subscribes to the latest observable, outer observable on the stream. What exhaust does is, what exhaust did was it starts printing out 0A, 0B, and then when this emits a new observable on the outer stream here, exhaust goes, oh, hold on, I have not yet exhausted the previous observable, inner observable you gave me, and it lets that finish. Then, once that's actually done, it waits for a new observable. So at this point, this one is done. This began before this completed. So we actually never even look at this one. And then we see this emits over here, and we subscribe to that one, and we get 2A, 2B, 2C. We could also do switch. And what switch did is when there's a new observable, it just canceled the subscription to the previous one and immediately switched over or subscribed to the latest one. What switch does is it starts to emit the values here, so 0A, 0B, but then as soon as a new observable is emitted on the outer stream here, we immediately cancel our subscription to this guy, and we subscribe to this one because it's newer. So we go 1A, 1B, and then as soon as an observable emits over here, we cancel our subscription to this one and immediately subscribe to this one. And so then we go 2A, 2B, 2C. So this practice of mapping a value to an observable and then using a flattening operator to get the inner values is so common in RxJS that there's a single operator for a lot of these combos, like switchMap. So instead of mapping and then switching, we can just switchMap and do it in one operation. And if we go ahead and run that, we'll see it does the same exact thing as doing it in 2 separate steps. So second observable starts, we switch over to that. And there are versions of this for concat, like concatMap, and mergeAll would be mergeMap. And there is also exhaustMap. And these do the exact same thing as their counterparts that I just showed you.